says, what is the measure of angle RSQ? Which angle is that? So RSQ is right here. Oops. Right there. Well, in order to find that, we've got to know some things about the notation of the triangle and what it's telling us. And what is that? Like, what is the notation telling us to do? Or telling us is true? Good. So what kind of triangle is it? What kind of triangle is PRS? Isosceles. What else is true about an isosceles triangle besides just those sides being congruent? Yeah, good. So angle P and angle R are congruent. I shouldn't put a symbol there. Let's just write 31. Okay, those two angles are congruent. Good. And I kind of covered it up that the fact that those two angles are congruent is a pretty big deal, because what is that telling us about QS? Oh, nice. It tells us that that is perpendicular, which makes that a perpendicular bisector. Okay? A lot of things you had to conclude just based on notation and knowing what the notation implies, right, about theorems. So it tells us that QS is a perpendicular bisector in an isosceles triangle. And so our name for that was the isosceles, let's abbreviate the heck out of this, isosceles perpendicular bisector theorem. That's what we're using, okay? Anyway, with that, angle QRS is 180 minus 90 minus 31. So now we're looking just in that triangle, and we know two of the angles. We know a 90 and a 31. So we can just subtract those from 180 to get the angle. What is 180 minus 90 minus 31? 59 degrees. Okay? Any questions on that one? All right, and then continuing with the notation, or the same problem, PR, because I put those double tick marks on those two segments, PR is just 8, just 2 of the 4s. So that one was quick. Okay, just wanted to do a little review of isosceles triangles, since we haven't done them. Not like this, at least, for a little bit. How'd that go? Give me a thumb somewhere. Okay, all over the place. One thing to keep in mind is as we get closer, and we only are really 1.5 sections away from the end of this unit, so we're not that far from being done and testing on the unit. And when you get to that point in geometry, things can start to blend together and forget what you're looking at, right? So keep studying theorems, keep maybe looking at examples and stuff. And let's look at these two problems. I showed you these yesterday. What does this tell us? And I don't want you to read it to me because we all can read it. What does it tell us about that picture? Yeah, but what does that tell us about the picture? You're right. But that's what it says. What does it imply? What does it communicate to us about the picture? So it goes pretty deep, right? So I'm asking, what is that deep stuff? What? Okay. Okay. You got part of it.
The CPCTC.
Good. He's talking about CPCTC. Okay. What does that stand for?
One's triangles are proven to be corresponding leftover parts that were not used.
Awesome. So we're told this. CT, congruent triangles. We know they're congruent. I mean, it's specific ones. Make sure you're looking at the right thing. But we're told that two triangles are congruent. Therefore, congruent parts are congruent, right? I'll say it this way. Congruent parts are congruent. That's now true because we're told that the two triangles are congruent. Okay? That's a really big result because now anything that goes together we can set equal. Anything that corresponds or matches up we can set as equal. So it's telling us to solve for P and Q. I'm going to give you a second to try that. Let's do P first. So we know that corresponding parts are congruent. I'm going to change this just because we're told this. So this is true. Corresponding parts are congruent. Well, what is a corresponding part with the part that has a P? It's 20, yeah. Okay? So WX corresponds or matches up to ZY, which means those two parts are congruent, and we can set them equal. So 7P plus 13 equals 20, so P is 1. Okay? How about Q? Well, be careful because it's easy to see it as these two pieces. Is that true? Does anything up here tell us that those two pieces are congruent directly? Like, no. Because those are only part of a triangle, like part of a triangle, right? The actual side lengths that are congruent are these whole pieces, like the whole longest side. Okay? So the reason I say be careful is because in this one, it is true that 2Q plus 3 equals 11, but only because we're told that both of those are 5. If they were not, then we can't set pieces of pieces equal, if that makes sense. Okay? This one, you probably, even if you miss that, it's okay, but it's really this that's true. 2Q plus 13 plus that little 5 segment equals 11 plus 5, right? But we see that the 5's cancel, so it didn't actually matter in this one. So 2Q, I'm not even going to deal with the 5's because they cancel. Alright, so Q is negative 1. Well, just to see if you're awake. I don't know. Why didn't you say it back there?
We didn't see it at first.
Alright. That better? Okay. Good catch. How'd those go? Okay. Guys, do you at this point, we're about a quarter in. Do you realize geometry is a lot about seeing relationships? A lot of the solving is easy, right? It's really about seeing what the picture shows or could show if we mark some more relationships on it. It's a really big part of this. Just real quick review. Why is AC congruent to itself? Reflexive property, good. I don't know how much more examples of this. I think, are we ready to just work on this sheet some more that we started yesterday? So the front side, let's go ahead and finish it up. About how far did you get yesterday? Like, let's say things like a quarter, half, 3/4. How far did you get through that? Well, I'm just looking at her. She looks like she's about halfway done.
A quarter.
Okay, so a quarter. So 15 minutes. Let's check 15. That puts us to 12:30, roughly. Okay, when I first look at this, I see this line that's congruent to itself. So now we have angle and a side. Can we get anything else? Like legitimately, you're not making assumptions? No. Okay, here I see these two vertical angles are congruent. So angle, sorry, no angle, side, angle, side on that one. I like this one because it reviews parallel lines. So let's talk about that first. Actually, I don't want to highlight that one. Highlight this one. And you see how we have on this, that, and that are what kind of angles? Alternate interior. Okay? So we have alternate interior angles there. And then, get rid of all that. Then if we look at these two parallel lines, same transversal, what do we have from that? Maybe turn your head. You see how those are alternate interior as well? Okay, these kind are really good for training for proofs because that might be all you're giving. Like if we had names like A, B, C, D, I might say AB parallel to DC and AD parallel to BC. And that's your whole given. And then you need to prove the two triangles are congruent. So you've got to remember AIAT, the alternate interior angles theorem. But we also need this side. And why is it congruent to itself? Reflexive property. So we basically just talked through a proof. Angle DAC and ACB are congruent by AIAT. ACD and BAC by AIAT. I know that's a lot of letters, but by alternate interior angle. And then AC is congruent to CA by reflexive. Triangles are congruent by, let's put these in here. Oops, I did that backwards. There we go. What is the reason for those two being congruent? A, what's this? S, A. Everybody see angle, side angle? Huh?
I got it.
Okay. Alright, next one, same stuff. We're shown that two angles are congruent. And we have to keep in mind that that line is congruent to itself. That's what reflexive property means, congruent to itself. So if I look at this, I see angle, angle, and side. Or you could go the other way. Side angle, angle is fine. Alright, next. Okay, so first of all, there are 5 triangles in this figure. Do you see that? And this doesn't tell you, it just says the triangles. So it's a little bit vague. But the two we're trying to prove are these two. So that one and then the other side. The two kind of facing ones. How do you know that's the two you're trying to prove? What's the clue?
Overlap each other.
Yeah, they overlap, and it's that 90 that tells you something about one of the angles. Okay? Alright, well, and it's not shown up here, but those two sides are also congruent. Okay, as soon as I see a 90, I'm thinking possibly HL, hypotenuse leg. Is it always? Definitely not. In fact, we haven't had it come up very often. I put L for leg. That's a side, and then an angle. Okay? Boy, we're really close to side, angle, side. Is there any way to get that second side? Can you do that? Can we do that another day?
Oh, yeah.
Is there any way to get that second side? This one's tricky. Do you see this length right there? It is part of both triangles, isn't it? With overlapping, it's often nice to draw the triangles separately. So I'm going to draw this right side, and then draw the left side, and guess what? Do you see how this OU is on both bottom parts? And do we agree that OU has to be congruent to itself? Okay? So even though it's not down the center, it's still reflexive. Because all reflexive means is congruent to itself. So this is side angle side. How about this one? Hopefully those vertical angles jump out at you. And then we have this little tiny arrow. What does it tell us? It tells us those CA and TO are parallel. So with that, just because of those two little arrows, we have these alternate interior angles, but we also have these alternate interior angles. And there we go. So we have stuff all over the place just because of those two little arrows. So tell me two different ones that we could use on this. Yeah, so blue, pink, blue. That's angle, side, angle. Well, we only have one side though. Side angle side requires two. Good. Yeah, so if you start at the side, side, angle, angle, or if you start at the angle, 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 side, either one. It's the same. How many of you caught that there were two sets of alternate interior angles? Keep your eyes open for those. Alright. So these three all reference this same picture, and definitely you need to make sure you draw a picture. These are so much easier with that. The only thing is the things that are congruent change. So let's get rid of those just for a minute. But the triangle size and name is the same. Okay. First one, EF and NO and angles N and E. So EF and NO. Sorry, I'm marking in the wrong spot. EF, NO, and angle N and E. And it wants us to prove this by angle, side, angle. So what else has to be congruent in order to do that? Do you see angle, side? F and O have to be congruent for angle, side, angle. Okay? So angle F congruent to angle O. Alright, next. EF and NO and angle N and E. Now we want to do angle, angle, side. So in order to do the side not between the angles, which angle has to be congruent? D and M. Good. This is way easier when you have a picture, huh? Okay? And then D and M are congruent. F and O are congruent. Let's do 2 tick marks. Now we're doing angle, side, angle. So DF, that side in between, has to be congruent to MO. And finally, lots going on here. Find the value of D. Oh, by the way, don't gloss over this. Otherwise, could we even do this? No. What are we actually using to solve this? This whole, like all four of these, what are we using? Good. CPCTC. Anyway, here's a D. What does it match up with? Right? So anytime you can't tell, remember to go back to your name. So does angle H go with angle D? Yeah, they're both the first letter. Okay? Because this is a little bit tricky to tell. So yes, angle D and H go together. So we do 2D minus 12 equals 58. And so this is D is 35. All right, P, I see a P here. What does it match up with? Well, EF, that's the second two letters, has to go with KL. That's the second two letters in the other one. So EF to KL. There it is, KL. So 8P minus 5 equals 27. So P is 4. How are you doing on matching up your corresponding parts? Is that going okay? Good. C is part of DF, so that's first and last, which means it matches up with HL, that's first and last. But so 5C minus 18 equals 32. So let's see, let's just send it down there. So C is 10. And find the value of R. R is now an angle. What angle does K go to? To E. So 4R minus 8 equals 76. So 22, that's not it. 21. Good? How'd the whole thing go? Alright, so that was a review of can we prove congruence and CPCTC solving. That's where we are. Flip it over. Our last stuff is proofs. So I want you to notice let's start with these bottom two. You're going to come across, to conclude the unit, you're going to come across two types of proofs. One, and what we'll focus on first, do you see how both of these ask us to prove that a triangle is congruent to another triangle? Okay, so proving triangle congruence. And then the one up here is asking us, at the top, oh, never mind, I misread it, it's the same. The other type will have us do this as a step before the last step, and then it will want us to prove, like in here, let's say, it wants us to prove angle S and A are congruent. Okay, so once we know triangles are congruent, why are corresponding parts congruent? What is that reason? Once we know triangles are congruent, why do we know corresponding parts are congruent? CPCTC. Everybody say it? Okay. So the other type of proof is prove triangles are congruent, but conclude by proving parts are congruent. So they will always conclude with those steps, with that step I mean. Okay? It's just a little extension of what we're about to do. So let's look through these and do them together as examples. So angle, or not angle, but side length LA, what does that symbol mean? Parallel to, so this is given. And notice we have two givens. In this case, they're split. It's kind of weird. But do you see it in our proof? Yeah. Do you see where that is in our proof? So go down there and write given there too. We haven't really, when we write our own proofs, we haven't really done it separate like that, which is fine. All right, our goal is to prove that these two triangles are congruent, and LA and SN being parallel is already marked in the figure, and so is the side length congruence. So, without looking at their logic, can you prove these two triangles are congruent on your own? Here's what I want you to get in the habit of doing. So everybody do this with me. Let's make our list and use it as a checklist, or more of like a check-off list. All right. Those two, remember in our paper we divided this, those two have two sides or more, right? Then our next group has two angles, so those two. And then our last one is the oddball. So here's how I want you to think through these congruence proofs. Each time I think you should write these down because it really helps narrow down your direction. Right now I know one set of sides is congruent. How likely is it that I'm going to get two more? Do you see any way to prove that all the sides are congruent? No, me neither. Okay? So let's kick that one out. We're not just doing it at random. We're saying there's probably very little chance of knowing that all three sides are congruent. All right. In order to use this one, I would need another side. Right? So right now we know these two sides are congruent. Do I know anything about LA and SN being congruent? No. How about AR or SR?
Can we use those little parallel marks next time?
Yep, we will. So we're not going to get that either, right? Okay? Is there a right angle? No. Okay, so that quick, we're down to knowing that we need two angles. And we have none marked, but we can get some. Like what? Like just don't even, let's just ignore theirs. Let's just talk through this. Go ahead, Kyron.
You know that A is like an angle because it's congruent to L and R? Like, how to explain it kind of, but like, since L and R have that mark, does that make A an angle?
I mean, A is an angle right there. Am I misunderstanding? You might be onto something, but I really can't tell what you're saying. Okay, we'll help you out.
Since the two line like set are parallel, doesn't that make each of the angles congruent? So like angle L and N are congruent, angle A and S are congruent.
Here's what she's saying. What kind of angles did I just mark? Alternate interior. And then she said this. What kind of angles did I just mark? Also alternate interior. Is all of that valid? Okay. So, just like that, we have two angles, right? I'm going to mark them. We haven't put it in our proof, but I'll mark them. And these are AIAT, alternate interior angles. What else could we put in here? I see one more thing that's congruent. Do you see these vertical angles? Okay, now we have stuff going on all over the place. So we know it's going to be one of these, or perhaps both. Could we do angle, side, angle? L is an angle, side, angle, right? Can we do angle, angle, side? A, L, and then the side, right? Or we could do A, the vertical, and the side. So just speaking through that, that's already 3 different versions of this proof. Which is awesome, right? It's nice to have flexibility. And honestly, we could write our own now without having to use that one. But let's go ahead and finish this one. Y, R, L, and N congruent. Alternate interior angles, good. Okay, LRA, so I'm just on step 4 now. LRA, NRS, so why are those two congruent? Okay. So this proof, like again, we had our flexibility, but this proof chose not to use those two, which narrows it down to just one of these, which is which one? Angle, side angle, good. That's a proof. That's a triangle congruence proof. They're very often only 4 steps, 4 or 5, maybe 3 or 4. So they're usually pretty short. What do you think? And these ones often have more than one way to do it, so it's good to have variety and flexibility. Okay, let's do the next one. O is the midpoint, that's just given. We also have O as the midpoint of NP, so where should that go?
3.
Yeah. I don't like how these are split, but so we won't. I mean, you can, it's not like it's wrong, but I'm not going to do mine this way. Now, do you see these tick marks in the picture? They are not stated in the proof. You see that? Why are they in here? Like they're not given, but suddenly they're just appearing in the picture. Yeah. True, but why do we know they are congruent? We don't have 90s.
Just parallel.
We don't have that either. We don't have reflexive. I'm glad you keep trying. Okay? Here's what I want you to know. Your proofs will not have that on there. So I want you to try to think of this proof right now as here's 2 givens, prove it. Right? How are you going to know to mark those congruent pieces? That's really what I'm trying to ask you. Okay? If you have none of this, and all you're told is that we have some midpoints, right? Those 2 midpoints. How are you going to know that these 2 segments pairs are congruent? That's my question. What is a midpoint? It's right in the middle, which means it does what? Do we agree on that? If you didn't hear, she said it splits those segments in half, right? That's what a midpoint does. Okay? So if it says O is the midpoint of MQ, doesn't that mean that these are split in half? Right? It has to, because it's O is midpoint. That's what a midpoint does. Okay? Alright, let me get rid of all this stuff. There we go. So, definition of midpoint is why we're doing this. So, MO is congruent to, what is that? Is that a Q, looks like? To QO. Why is that again true? Definition of a midpoint. Yep. Alright, and then similarly, NO and PO are congruent. Okay. Why is angle MON and QOP congruent? Let me mark it. MON, QOP. Everybody see those verticals there? Did we have to pick that pair? We did, because this triangle, these are the triangles being proven, but it could have asked us for the other 2 triangles and we'd still be in the same spot, right? Alright. Well, what theorem is that proves those 2 triangles are congruent? No, that proves these angles are, but I'm saying now, these 2 triangles, why are they congruent? Everything's marked. Except for I have 2 sides. Side, angle, So, does everybody see it? You good? Okay. Alright, why don't you try that last one? What should you never get wrong in a proof? Forgiven, yeah. Are those marked in our picture? No, so anytime that something's not marked that is true, you should definitely put it in there. So this one, angle T is congruent to angle Q. That's something you can directly mark. This doesn't really have a marking, does it? But what is the implication of that statement? What is? Not two triangles. What is? Split in half. This is very specifically one thing split in half, not a whole triangle. What does bisect mean? Split in half. What is being bisected based on that statement? The angle TSQ, right? Which is this angle. So there's this 1 and 2 there. What is true about 1 and 2? Okay, alright, that's something we can mark. So I want you to make sure you're clear on this. Let's cover that up. I'm going to mark this, but notice it is not in here. Do you see that? SR bisecting TSQ, angle TSQ, that's in here, but angle 1 and 2 being congruent is not in our proof. So mark it, but make sure it's in here. Why is angle 1 and angle 2 congruent? No. Complementary ones add to 90. How did we know to go mark those? It's bisected, right? So 1 flows right into 3 because of the definition of angle bisector. Okay? In other words, take that statement that it's bisected and translate it into a meaningful picture. All right. What else do we see in the picture that could be marked that's not? Yeah, you did it, right? This. What's he talking about? Say the side length name. Where do we put this? Yeah, you're right. That's the property, reflexive property, but what are we talking about marking? Yeah, the middle line, which is called what? Oh, what's the name of the line? SR. SR is congruent to, and we usually reverse the letters, so it's like going both ways. Right? So RS, or SR congruent to RS. If you forget that on a proof that you do, I'm not going to mark it wrong, just so you know. It's okay to say SR congruent to SR. You'll just see it most of the time reversed. And that was reflexive. Now I need to mark that in the picture. Okay, according to this, we are one step from done. So what's the last line? Yep, this thing we're trying to finish out with. So triangle RTS congruent to triangle RQS. But why? Look at our picture carefully. Yeah. He said angle, angle, side. Or if you read it the other way, side angle, angle, that's fine too. How'd you do on yours? Line 3 is probably the trickiest one. Otherwise, the other ones we've done quite a bit. So that's congruence proofs. Okay? So I just handed you a packet. Why don't you try, just to finish out, try the first one. Just the first one on the front page. Okay, I tell you what, I'm just getting you set up here, but if you haven't finished this, why don't you work on it tonight, and we'll check it tomorrow. Make sure you're doing your checklist or check-off list. I think it will be helpful.